Good morning, students. Today I'll solve Mathematics Syllabus D, Paper 2, 4024, Variation 22, October-November 2018. And this is calculator version. The first question says, Kamal earned a total of 32,500 in 2017. He paid 9% of his amount into his pension. He paid 22% tax on the remainder after 9.5% of his earnings as tax. Calculate the amount left after paying his pension and his tax. Now let's find out how much he paid for tax. So 9% of 32,500, that's for pension. Let's put P for pension, and then it's a 9%, 9 divided by 100, that 9% times 32,500. So 29.25, that's the amount he paid as pension. Okay, what is left? This remainder. So remainder would be 32,500 minus 2,925. So 32,500 minus the previous answer, it should give me 29,575. Okay, now he paid tax. Okay, so for tax, 22% of this remainder. Okay, that's 29,575. So I'm gonna have 0.22, 22% means 22 divided by 100, that's 0.22 times 29,575. That should be giving me $6,506.50. Okay, so that's that. Now it says calculate the amount left after paying his pension. Okay, this is the pension. Okay, this is pension and this is the tax. Okay, what is left? So initially he got that 32,500. From that I need to subtract these two. That's what they're asking. Okay, so let's see. 32, the leftover money. Okay, that's whatever left, amount left. You can write down amount left. 32,500 minus 2,925 plus $6,506.50. So 32500 minus 2,925 minus 6,506.5, that gives me let me write down the whole thing first. It's gonna be $23,068.50. Okay, you can keep it like that because this is exact amount. 2, 3, don't need to do three significant figures right over here. Okay, if you keep it as it is, this is the right answer. Don't try to keep it in three significant figures over here. Okay, so that's the final answer. I put it in a box. Now next one, B. Kamal invested $1,200 in a savings account paying. So $1,200 paying, this is the rate, okay, 1.8% per year compound interest. He left the money in there, the account for 5 years. That's time. Calculate the amount of money in the account at the end of 5 years. Give your answer correct to the nearest cent. Okay, every important thing, just underline that. We know that amount equal to P1 plus R percent or R by 100, then you can put N or T. Okay, that year, time in year. Okay, that's what you are learning in O level. There are other formulas, but this is the formula we're gonna use. So principal was 1,200, and then 1, and rate is 1.8 divided by 100, and time is 5. Okay, now you can use the calculator. Be careful you are using it correctly. I'm gonna go inside out. 1 plus 1.8 divided by 100. Okay, so that's gonna give me that to the power 5. So I got this part times 1,200. So it's gonna be 1311958616. I put all of them here, okay, just to show you something. Now it says the nearest cents. Okay, so nearest cents, usually we put nearest cents in two decimal places. Okay, the third one is 8, so I'm gonna put over here one more, so it's gonna be 1311.96. That's my final answer. Okay, all right, C. Kamal also invested some money, it didn't say how much, in a different saving accounts for the same time 5 years. This account paid 2.1%, that's the rate, per year, simple interest. Now it's simple interest. Previously it was compound interest, now it's simple interest. The formula is completely different. At the end of 5 years, there was this much in the account. So this is amount. Okay, not the principal. Calculate the amount of money. Even though it says amount of money, non-speaking English students, they sometimes got problem with that. Amount of money he invested in the account. They are asking for the principal. Okay, now we know that, okay, amount equal to principal plus interest. Okay, now over here, amount, I know amount is $828.75. Now P, I don't know. They are asking for P. So I'm gonna put P. Now I hope you know the formula for I. Formula for I is PRT over 100. Now there is this mnemonic. You're gonna love that. If you don't remember that, okay, then you can use this mnemonic. Look, I am pretty. Okay, I interest, pretty, PRT, that pretty, I am pretty, so I equal to PRT over 100. This is easier to remember. So that's gonna be P, I don't know, so I'm gonna put P. R over here is 2.1 and time is 5, and this percentage, that 100 comes below over here. Okay, now what can I do? I can do 828.75 and LCM. When I do the LCM, the denominator over here is 1. So LCM is 100. So that's going to be 100p plus 2.1 times 5. That's going to give me 10.5. So 10.5p. So over here, if you bring this 100 over here, this is going to be 82875. This point cancel out because it's multiplied by 100. If you are not sure, 828.75 times 100. See that? 828.75 times 100. That's 82875. Point just vanishes. Okay. And over here, 100p plus 10.p. That's 110.p. So 100 plus 10.5. I don't know what did I just said. 100 plus 10.5. 100 plus 10.5. That's gonna give me 110.5. So 110.5p. Therefore, p equal to, transpose this one over here. So it's gonna be 82875 divided by 110.5, and that should give me 82875 divided by 110.5, and that's 750. So this principal was $750. Okay, I put it in the box. All right, make sure you write down in answer. Okay, space, wherever the space is given for answer, write down there. Okay, and if you write anywhere else, make sure you just put a box and put an arrow from here. If your answer is over here, make sure you put that arrow. Okay. All right, next one. The exchange rate between dollars and pounds is $1 gives you 0.72 pound. The exchange rate between dollar and euros is $1 equal to 1.10 euros. Kamal has 200 initially, $275. That's Kamal has. Okay. He changes part of $275 into pounds and received that many pounds. So how much he spent, he exchanged, it didn't say. Okay, but he received 79.20 pound. Okay, so we need to find out how much he exchanged, how much dollar, how many dollars he spends for. Okay, now this is a rate given, the relationship between dollar and the pound, right? It's 0.72, and we know that he spent sum of the dollar, and we don't know, exchange sum of the dollar, and let that dollar be X. Okay, and he received 79.20. So you can cancel this and that. So X is gonna be, if you transpose this one, 79.20 divided by 0.72. I'm going to use the calculator. 79.2 divided by 0.72, it was $110. He exchanged $110. Okay, so the rest of the money, okay, rest of the money, okay, he changed the remaining, this rest of the money equal to 275 minus 110. So 275 minus 110, that's, he left with $165. He changed the remaining dollars into euros. This into euros. That was pound and now in euros. Calculate the amount of money he receives in euros. Same thing. $1 equivalent to euros is 1.10. So he got $165 and we don't know how many euros he got. So let it be Y. So I'm just gonna use this space over here. So that's Y equal to, transpose this Y to that side. So dollar cancel out, and then this multiply by that. So Y equal to 165 times 1.10. So 165 times 1.10, that should be giving me 181.50. Remember how many euros? So this was euros. The unit is given. All you need to put 181.50. Okay, so that's done. Okay, next question. Question number 2. Lim grows tomatoes. The masses m grams of 200 of our tomatoes are recorded. So 200 recorded. The cumulative frequency table shows the result. So less than or equal to 80 is 0, less than 100, less than 100 or less than or equal to 100 is 20, less than or equal to 110, 48, something like that, right? And then it says on the grid, draw the cumulative frequency diagram to represent this result. So everything has done for you. And you know that this is the x-axis and this is the y-axis, okay? And this is x-axis, this is y-axis. So 80, 0. This is the coordinates you have to follow. So 80 is going to be 0. I'm going to use a different color so you can see that. It's right over here, 80. So 80, 0, it's 80, 0. And then x is 100 and this is 20. So 100, this is 20. Okay. Then 110, 48. So 110 and 48, this is 40. Now, exactly in the middle is 50. So I'm gonna go somewhere. This is gonna be 45, 50. So it's what, 48, right? So 50 somewhere over here. Okay. And then 120, 112, 120, then 112, 48, then 112. This is 100, and this is 10. So 12 is somewhere over here. Okay. And then 130 and 158. 130, 158, almost like 60. It's right over here. And then 184, 140, 184. 140, 184 somewhere right over here. And 160 is 200 right over here. Now I can draw this cumulative frequency graph. Okay, connecting those points I just got. It does look like an extended S. Okay, this one. Okay. Okay, so this is a nice one. Use your diagram to estimate the median. Now median, you know that median is 50% of cumulative frequency, or you can write down half. 50% means 50 divided by 100, half of cumulative frequency. It doesn't matter whatever you use. Okay, 50% of cumulative frequency. So 50 divided by 100, And cumulative frequency we had up to 200. You can see that in the table, or you can see in the diagram over here. So 200, so 0 0 0 0 cross out, so that's gonna be 100. So this is 100 over here. I'm going to use a different color, and this mark should be on your graph. Okay, without this thing, you don't, this mark, you don't have any proof what did you do. Okay, and then this one was the 50% of the cumulative frequency was here. Okay, that's 100, and then it intersect the graph at this particular point. So you need to draw this line over here, and this is our median. So 110, here is each of them is 2. So 112, 14, 16, 18. So median is going to be 118 gram. That's my median. Okay. The interquartile range. I hope you know that interquartile range is Q3 minus Q1. And Q3 is, I'm just going to do this over here. Q3 is nothing but 3 by 4 or 75% of the cumulative frequency. And over here 200. So that's going to be 50. Okay. And that's 50 means 150. 3 times 50 is 150. So what I'm going to do, I'm going to use a different color. So 150 somewhere over here. And again, you have to have this marking over here. So that, and I got over here 128. Okay. So this particular value, this one over here is 128. And then of course I need to find out I have to find out Q1. Okay, that Q1 is 1 by 4 times 200, so that's gonna be 50. So this is 50. So when you go for 50, again, this is 50. I'm using green color again. 50. I'm getting over here 110. So this one is 110. Okay, so my cumulative frequency is 128. Q3 is 128 and this is 110. The way I have done, I got 18. So this is 18. Okay. All right. Now next one. Ravi also grows tomatoes. The masses of 200 of his tomatoes are also recorded. For Ravi's tomatoes, the median mass was 124 gram and the interquartile range of the masses was 12 gram. So this is median. Median means Q2. So let me write down Q2 was 124 gram and interquartile range was 12 gram. Okay. Now make 2 comments comparing the masses of tomatoes grown by Lim with those grown by Ravi. Ravi grows that and Lim grows this, right? Now this is for Ravi. Okay. This information for Ravi. Let me write down Ravi. Okay. Ravi's Q2, that's median, is 124 and IQR is 12 gram. And lean, it was lean, right? Lim, sorry. Lim, Q2, that's median. Median was 118. Median was 118 and IQR, interquartile range, was 18. So 18 gram. Okay. Now make 2 comments comparing the masses of tomatoes grown by Lim with those grown by Ravi. Now the first one, we can see that average, this is the median, is average. Okay, Ravi's 1 and Lim's 1. Okay, Lim's masses of his tomatoes are less than the masses of the tomatoes grown by Ravi. So write down that masses of Lim's tomatoes are less than that of Ravi's tomatoes. Okay, Ravi's tomatoes mass. Okay, that's average mass. Let me put average. Okay, average masses. Average masses of Lim's tomatoes are less than that of Ravi's tomatoes. That's one thing. And for the next one, IQR, interquartile range, this is the interquartile range of Ravi, is less than interquartile range of Lim. What that tells you? We know that bigger interquartile range, if interquartile range of A is greater than interquartile range of B, that means it is more variant, okay, less consistent. This is more consistent. So since Ravi's tomatoes masses are interquartile range is less than Lim's, then masses of the Lim's tomatoes masses, average masses of Lim's tomatoes are less consistent or more variant. Okay, it's not consistent. One is bigger, one is smaller, and the variance is really big. But Ravi's one, since interquartile range is lower, it's more consistent. It's almost same size. Okay, not quite exactly, but almost. Okay, if you take more of it, it's more or less same. Okay, so that's what it means. So those are the 2 points. Now next 1D, complete the frequency table for the masses of tomatoes grown by Lim. So this one, 80 to 100, 20, 100 to 110, that's 28, 100 to 120, that's 64. What about 120 to 130? Now, let's go back to this previous one. Okay, 120 to 130. So 120 to 130. So 158, 130 less than or equal to 130 is 158, and 120 is 112. So 158 minus 112. Again, 158 minus 112. So that's going to give me 158 minus 112. That's going to be 46. So this is going to be 46. Okay. Now 140 and 130. So 140, 184. That's 184 minus 130. 130, we know that it's 158. So 158. 184 minus 158, that should be 26. If we add that, just to show you, 20 plus 28 plus 64 plus 46 plus 26 plus 16. What is supposed to be? It's supposed to be 200. Here, 200. Okay, so we are doing it okay. Write down the modal class. Modal class, you know that the frequency that appeared the most. Okay, if you look closely, 64 is the largest frequency we can see. So the modal range is this. So 110 M is greater than 110 but less than or equal to 120. Okay. Now calculate an estimate for the mean mass of these tomatoes. Whenever we are trying to find out the mean, I have to take the midpoint because it's range. So 80 plus 100 divided by 2. I'm just going to show you one. 80 plus 100, add this 2 and divided by 2, that should be 90. Okay, so I'm going to get here 90. And over here 100 and 110, it's 105. You can check that. Okay, 100 plus 105, 100 plus 110 divided by 2, that should give me 105. So I'm not going to do that every time. You can just check that. 110, 120, that's going to be 115. And then 120, the mid number of 120 and 130, 125. And over here 135. And over here 150. Okay, so the mean should be, okay, this number 90 times this is the x, okay, mid value or x. I can put that mid value, or this one we commonly say that x, okay. So that's the another column we have drawn to find out the mean. So 90 times frequency 20 plus 105 times 28, okay, just put it in the brackets so it's not going to be a confusion. 115 times 64 plus 125 times 46, I'm running out of the space, plus 135 times 26 plus 150 times 16, all of them divided by, remember it was 200 the total, so it's 200. So what do we got here? So clear the calculator. So 90 times 20, then plus 105 times 28, 105 times 28, plus 115 times 64, plus 125 times 46, plus 135 times 26, plus 150 times 16. That should give me 23,760 divided by 200. It's always better to check that once again, okay. And the thing I got 118.8, it's close to the average, the mean, we got that, the median number over here. So I think we are okay, okay. So that's the average of this tomatoes mass, okay. All right, so next questions I'll do in my next video, okay. Thank you, have a good day.